We are table number 23 and we're recording this on the 28th of September. Today's video is going to be about the step response of an RC circuit. We're going to be using this circuit over here and we will be measuring the output voltage and the input voltage with the oscilloscope of the MyDAC. On the screen you can see the step response using an 100 Hertz frequency. We're gonna be using this graph in order to calculate the RC time.
So here is the data that we have got, and this is the time, this is the voltage out. The first point we have calculated the RC time 1.26 milliseconds, and another point we have calculated the RC time 1.48 milliseconds. So we can conclude that this data doesn't represent a high accuracy, but it's a decent accuracy.
We also calculated the RC time considering that the capacitor and the resistance are ideal, and we got a result of 1.0 milliseconds, which is very close to what we got in practice. We are using a period for the signal of approximately 10 times the RC time. This is because it takes approximately 5 times the RC times to fully charge and other 5 times to fully discharge. Now we have interchanged the capacitor and the resistor to get an CR circuit, and now we can observe the difference in the square wave. The main point to notice now is that now is not a low pass frequency but a high pass frequency. As we can see, as we decrease the frequency now in 10 Hertz, the voltage that makes it through is practically zero. And as you can see in this part, when the voltage is constant, the voltage out is going to be zero, showing differentiating behavior. Lastly, we have the triangular wave, which shows a similar behavior as the square wave in terms of the output, but this time the amplitude is smaller.